We haven't worked.
It's going.
Or maybe you
Okay.
guys have. We haven't.
So worksheet with KA and KB. So for this worksheet, you have to show all your steps. You have to state any assumptions, and I'll tell you some of those assumptions in a moment. Make sure your answers got the correct number of sig figs, and make sure your answer is the correct unit. And then that's somebody else's. So for our first question, does yours say, calculate the hydronium ion concentration in a 0.45 molar solution of hydrogen sulfide, H2S?
Yes.
Okay, so I'm gonna write down, what?
Should we turn back on the video?
Yeah, it's on.
It's on. So I'm going to write down the chemical equation here. So here's my acid. And this one, I'm gonna do plus H2O, which, what do I do when I'm doing KAs? What do I include? Not L's. What are the two phases that I include? Yes. And so we're gonna have, this will have the hydronium ion concentration and my HS minus.
Is this the first one you're doing?
This is the first one. Can you see that whole thing on there, guys? Can you see my whole thing on there?
Yes.
Okay. So here's our chemical equation. Now there might be a couple of things here that you have questions on. If I give you an assessment, I will tell you what the chemical equation is, okay? I will give you the chemical equation unless it's one you should absolutely know, but I can't think of any you'd absolutely know. Yes?
What's the thing that you highlighted, like underlined a lot?
That's a liquid. Oops, I should have put an AQ here. So when I do I'm gonna do a rice table now.
Oh, no.
And I'm told, so we're gonna figure out what we know here, and I'm gonna talk to you about some assumptions that we can make. And they're assumptions that you can always make as long as you're in this level of science. And then I'll talk about when you can't make those that you'll never have to do, but you guys could actually do these pretty easily because it's not hard to solve quadratic equations anymore if you have a graphing calculator. Do you all know that?
Yeah.
You just pull up your quadratic equation solver and plug in your coefficients and it gives you your options. Pick the positive one, because you can't have a negative concentration. Do you all know where your quadratic equation editors are?
No.
Good Lord, people.
Well, if it's
Somebody hand me a graphing calculator.
They're teaching us important concepts.
Wait, they don't tell you how to plug in a calculator. Yes, he has.
That's fine.
We went to have
What?
How do you not know how to solve for zeros? Just hit zero and then go left to the zero, right to the zero.
Yeah.
Yes.
Yeah, I can't do that right now because I'm start talking.
I don't know.
Okay?
You go second, you go no,
Yes.
Oh.
Okay. Go down, press your apps, press apps.
Yeah, do you have any extra of those worksheets?
I can type this. You see apps. Now go down to number 8, 9, or 10. It'll say PLY SMLT2.
Oh, I don't know.
And then you can do your poly root finder. And if you pick your poly root finder, you pick your order. It's 2 if it's a second degree, so you can do like something with a cubic root or whatever. So you pick that 2, and then you put your coefficients in, and it gives you your solution. Pick 2. You don't need to do that today, but if you're doing you guys know what I mean when I say this, an x squared plus some number x plus some number. You can solve that right here. Just choose it. And then go down to okay. You guys can do that on your own time. But sorry to my third period people or people watching this. We're learning to do something very valuable in our calculators right now. Who thinks they're going to use that someday? You don't need to use it for me because I said you don't need to. but it's something you can use a lot in your math classes.
I need help.
What?
I'm lost. How do
You don't have to do that on here.
But we'd like to know for the future. Yeah.
I will show you after, later. I can't do it now. No, no.
It's all sorts of.
Okay, guys, regrouping, regrouping. So that is just something I was gonna say you can do easily now. I'm not going to make you, because it was a big headache. It takes forever to do those the old-fashioned way. Who knows what I'm talking about? That, you know, plus or minus AB plus whatever that whole square root thing is, plus whatever. Yeah. So this will solve it for you, simply by putting the coefficients in.
For the something piece.
Now, guys, let's zone back in now. When you're working on these problems, you can do these different orders. I like to write down my KEQ expression, but this will be a KA expression. Do you agree?
Yeah. Why did they change the name?
Because acids, we want to know we're talking about acids. So my KA expression will be my products, my concentration of my products, divided by the concentration of my undissociated acid. And those will be the numbers we put in right here. Do you all agree with that? Whatever numbers I get right there will go into that equation. Now, something about this worksheet, and I told you not to start this one back in the day. There is a number here that you were not given, that I'm giving you now. Ka for this one is 9.1 times 10 to the minus 8. I would provide this for you. Whoever had this worksheet out just handed their kids a list of KAs or told them which table to look at. If you're ever looking at something, you type in Ka of H2SO4 and it would tell you what it is. Is that clear? If you ever run across one you don't know what the K is, just look it up. Are you clear on that? It's easy. Just look it up. So that's what we're given here. Now, we are also told in this problem that we're starting with 0.45 molar this. Please locate that and make sure you know that. Do you all see? Read the problem. Do you see where that number came from? And before it starts dissociating, what are my concentrations of these two? So, now, so far, I'd like everybody to take a moment and make sure you know how I wrote that Ka expression up there. Do you?
Why are H2O and H3O the same?
H2O is not included because it's a liquid.
So it just, okay,
That's why I just made a big.
perfect, thank you so much.
Does that need a label?
It is always concentration in here, so I generally leave them off. But if, I will put an M in here for you.
Good for you, Jack.
Okay? Now, so we don't know much of anything else here. I do know this. I do know that all my coefficients are 1. Do you agree? So I know this is going to go down by some number x. Do you concur? What are these going to do?
Go up.
So my final concentrations are going to be 0.45 minus x. That was easy, right? And what will this be?
X.
What will this be?
X.
Okay? So far, this doesn't look bad.
No.
Now, I'm going to put a squiggly line right here. This isn't bad. The important thing is to keep organized, label, label, label. Now I want you to watch what I'm doing and I'm going to explain this. I'm going to take my given number, 9.1 times 10 to the minus 8, equals, hey, if these are both x, what does this turn to?
X squared.
Oh my gosh, x squared over what?
0.45 minus X.
Now, I'm going to wait for a moment. Do you see that I'm on my way to a quadratic equation here?
Yes.
But I'm going to tell you something that is true. Do you see this 10 to the minus 8?
Yeah.
If that number is very little, And usually it's about 10 to the minus 4. You'll see some by 10 to the minus 3. If it's 10 to the minus 4, 10 to the minus 3, we get to ignore this because it's so insignificant. If I had all the time in the world, I would have you solve this problem using the quadratic equation solver and ignoring this. And you would find out, you can just trust me, that it won't even make a rounding difference. Do you understand what I'm saying? Because it's so insignificant.
Wait, so if it's like 10 to the third, just kind of.
If it, I'll never give you one.
Okay.
You'd have to do your quadratics then, because it wouldn't be insignificant. But if this is 10 to the minus 5, 10 to the minus 6, 10 to the minus 7, blah, 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 you can
Why?
ignore that.
Why would it make it insignificant since it's a bigger number? Because it
It's
is.
not a bigger number because this means, what this means right here is that a teeny tiny bit of this dissociates. Very little of it turns into this and this. Almost all of it stays in this.
So this
Four.
is a weak acid?
So it's 0.45 minus a teeny tiny
But-
amount.
But we're not, but it's not insignificant in this equation.
Yes, it is, because it's this
I
10
thought
to
you
the
said if
minus.
it's, I thought if it's 3 and 4, it's insignificant.
No, if it's 3 or 4, it's on the edge of insignificant.
Okay, so if it's more than that, well, I mean less technically. Like
This
if
is less, then you can ignore it. This is an unbelievably small amount.
So then,
So I need everybody to think through this
for
concept a minute.
Is bigger than negative.
So
I know.
in this, with 10 to the minus 8,
Number is bigger.
guys, listen, listen. Since this is 10 to the minus 8, this is a teeny tiny amount of this will dissociate. Almost all of it will remain 0.45. That will remain this. Just the smallest amount is going to dissociate. So that means when I take 0.45 minus x, let's just make up some fun numbers. What if it's 0.45, that's what I'm starting with, and this much dissociates? It's not even something I can legally round to on sig figs. Do you understand what I just said?
Yeah.
So if I do that math and follow my sig fig rules, it's so little I can't even put it in my equation.
Can you show us what that quadratic formula would look like though?
I'm not going to right now because we're not going to do the quadratics.
Okay, but you'll show us.
I'm gonna solve the problem for you now without the quadratics, because I'm never gonna make you use a quadratic.
Oh, really? Okay.
Yeah, I'm not, remember I said I'm not making you do the quadratics. Every problem I give you to solve, zone in guys, ready? Every problem like this that I give you to solve, you will be able to ignore this. I'll expect you to write it out like this, and I'll expect you, on my key I wrote assume 0.45 minus x is pretty much equivalent to 0.45.
Okay.
And that's a valid assumption. And I'm telling you it's a valid assumption if this is ever 10 to the minus a lot. Okay? And like, I'll just look ahead. On our next problem, we've got 10 to the minus 10.
No.
So we can assume that again. So now I'm gonna erase this. Now, let's go ahead and write this out. Do you agree that this is gonna solve to x squared equals 9.1 times 10 to the minus 8 times 0.45?
yes.
And then what am I gonna have to do after that? X equals, hey guys, come and see if you can see this. Can you see this on my screen? Equals the square root of this.
Yeah.
Can you see this?
Yeah.
Okay, now you may solve. This is as hard as these get.
Are these like weak acids?
Yes, because this is a weak acid. You can't do this with a strong acid,
What happens with the strong acid?
not this. There's 100% dissociation, so these are all zeros. All of this turns to a 0, and what happens when you divide by 0?
0.
Nothing. So you can't do this with a strong. What?
Undefined.
No way.
I got
2.02 times 10 to the negative.
I got, yeah, 2.0.
And since I gave you 0.45, shall we restate that?
Yeah.
2.0
I got 2.0
to the negative fourth.
times 10 to the negative fourth, and this is concentration.
Makes sense.
Is that the answer?
Yes,
But I thought you had to plug it back into your KA solution.
we did.
Oh, we
This
already
is-
did, we already did, we already
We
did.
did it already, we did everything. So now, let's think, folks.
Wait, that's doing it right.
Let's look at this, because I need you to think through this. We just solved for X. X, we were asked to solve for this concentration. X, there it is, this concentration, which is the same as this because there's a 1-to-1 mole ratio. Also, I'm gonna say this right now, I don't think I'll ever do that on an actual assessment. No, like none of these do I have any twos on the ones we're gonna practice. That gets really hard, because you can imagine, what if this turned to a 2x, so then I get a 2x squared, it gets harder and harder and harder. Does that make sense to everybody?
Yeah.
Now, we're gonna do another problem, the next one here. So what I would like to challenge everybody to do is you can't do it yet, because what do I have to give you that you're not given? You're correct. So I'm going to go ahead and I'm gonna write the KA up here. Let me make sure it's the same thing. Yes.
Do you have any extra of these?
I'm sorry, you asked me that. Hang on, everybody, I'll be right back. You asked me that, David, and I forgot.
I just did it on notebook paper, but.
Okay.
Sus. Your spit is actually getting.
There you go. Anybody else want one? I'm sorry. Anybody else want one? I better get a couple out for my class tomorrow too.
Yeah, I feel bad for you.
Okay. Hey, everybody, can you guys see this? This is what we're working on.
What?
Okay,
Anytime I say anything, you're like, oh, yeah.
now,
It's the only joke you know.
Oh, wow.
Okay, that's actually so.
That one is zero, it's very cool.
I told you guys about
I'm sorry, David.
for our next problem, I have pH. Now, this is gonna be easy, but I'm gonna tell you what we're gonna do in a second. We're gonna do the exact same thing we just did, and when we're done with that, I'm gonna have my H plus concentration. Once I have my H plus, we're gonna take the negative log of that number to get the pH. It's just adding a baby step. So for my rights, I have NH4 plus. And then we're gonna have our H2O, which I'm gonna write right there because I'm ignoring it. Do you all concur?
I concur.
And then I'm gonna have my H3O plus right here. And I'm gonna have my NH3 right here. Now I want to think about this for a moment. Let's read this. I have ammonium chloride. Ammonium chloride.
Yeah, where is that?
It said,
We didn't write down ammonium chloride anywhere.
no, I'm talking about that right now. I'm telling you why.
Okay.
So I have ammonium chloride. When I look at ammonium, I'm just gonna put my NH4 Cl right here. That dissociates into NH4 plus and Cl minus. That Cl minus is not going to, it's a spectator ion. It's not gonna do anything.
How do we know that?
I'm telling you. And I would give you that information in
So
an assessment.
Cl minus is always a spectator.
Not
Oh, just in this equation.
in this equation, because this NH4Cl, if you remember, these are always soluble. NH4 is very, no matter what it combines with, is really soluble. Cl is really soluble. So NH4Cl, when it goes into solution, all of it dissociates, all of it.
This is the strong acid.
It's not an acid.
Base.
This, not even that. NH4Cl,
Let's just go like the
how does NH4 act?
biggest can.
Like a monovalent metal. So this is a metal with a non-metal. This, NH4Cl, is like a salt that I can have in the back room. And when I put it in water, it turns into NH4 plus and Cl minus. Now, the NH4, I'm gonna erase the rest of this. I can find an eraser. That NH4 plus will then interact with the water, and one of these will, I should have my plus and minus right here instead. That should have been a plus, my bad.
Equation balance.
So, yes. So what happens is my water takes one of these to produce hydronium, and my other product is ammonia. So again, if you will recall, I told you I would provide you your chemical equations. So I wouldn't expect you to know this one on your own. Although we've used NH4 where we had to combine it. I gave you NH3 and we had to add an OH on there, correct?
Yeah.
We had to do that twice. Now I'm telling you I've got an NH4, it's got a Cl on, okay, we're gonna have to do something, let's just get rid of that Cl. So that equation you see right there, and I apologize to anybody watching this video that my writing is so bad. This is a plus.
Only square.
This is, I know it's gonna be a bad glare, there's nothing I can do. There's a nice arrow. So, but that I'd give you, so life is good so far, correct?
So good.
Now, let's write our Ka expression
Let's hope that I'm writing this correctly because I'm working on it.
is H3O plus NH3 over NH4 plus. Does everybody agree with that?
Yeah.
And I'm gonna tell you the magic number you don't have yet. It's 5.6 times 10 to the minus 10. How do you know that?
You told us.
And if I didn't tell you,
Oh my gosh, I was writing right.
look it up.
Look it up.
Write in Ka for NH4 plus. And it will say, depending, some of them might say a little bit better. Not every table is the exact same. But I would always give you that, yes.
So is ammonium the acid in this?
Yes.
And then also, will there be no like net ionic equation creation on the test, or?
I don't know the answer to that yet.
Okay.
Yes.
Why are the values different from table to table if it's a constant?
That's a good question. You know that you can find periodic tables that aren't the same? Let me just answer your question with that statement to tell you that's why.
Oh, isn't there like a circle?
Because scientists.
Answer your question with a question.
Depends on who's using whose data
Okay.
to figure these out.
Well, according to the AP test, scarcity is, you need to make questions.
Now,
to make choices.
so, ladies and gentlemen, this is the work we do just to get to this point, okay? We're gonna do the work to get to this point. And I want everybody to take a moment. Do you know how to write this?
Yes,
Does everybody know that this is a value you will be supplied? Nobody has to know these,
yes.
okay? There's a possibility I might give you all of these. You might know all of these on a really simple problem. And if you know this and this and this, then you can calculate your Ka. You concur?
Yeah.
So, you know, if you get all your values in there, then you're good. Now let's read the rest of the problem. We have a 0.60 molar solution of ammonium chloride. Easy, I was given that, correct? So it's ammonium chloride, and what will be my initial concentrations?
Zero.
And what's gonna happen?
Let's subtract X.
I'm gonna subtract X here, does anybody see where this is going?
It's still exactly the same as the last one.
Add,
X plus X.
This is not rocket science, and I mean that literally. This isn't rocket science. This is acid and base science. So,
No.
now, okay, that doesn't matter.
Don't
Now,
go too far there.
everybody, start solving.
Left first.
Start solving. I'm gonna write down the equation up here. Your goal is to be able to write it down, then look up here and get the same that I have written down.
Wow, I gotta.
If anybody's feeling brave, go ahead, multiply this out, and do your quadratic and try to put it in your calculator, see if it works. If you're feeling brave.
Oh, the admin.
If, I always have somebody who wants to do it to see if it's truly
Is this what
working.
you're doing instead of your
I'm not.
Then don't do it. So now, what am I gonna do next, folks?
Russian
Process
Yes.
X.
And I'm going to know that because, look at, this is even smaller than our last number. Even smaller.
That's exactly the last one.
So now I'm gonna get, I'm gonna take a little shortcut here. Guys, zone in. Remember, I've got this going so you can't be talking or they can't hear. Ready? So I'm gonna take a little shortcut here and skip that step. I'm just gonna go straight to this. Is that okay with everybody?
Yes.
So then I'm gonna have 5.6 times 10 to the minus 10 times 0.60.
It's not 1.8 times 10.
No, I see.
What?
1.8 times 10 to the negative.
Oh, that's my answer?
No.
1.8.
That's the answer, it's not your.
1.8, that's.
Yeah, you're supposed to
You have
pH.
friend
You're
Peter.
supposed to solve for pH.
Well, she's good so far.
Yeah.
I want
Yeah.
this.
She said that that was the answer to that equation. Thank you. Let
Now,
her live.
okay, and yes, you're right. This isn't our final answer. So now I know that this is my molarity, that is my concentration of my H plus. Do you concur?
Yes.
So now what am I gonna do?
Negative log.
Take the negative log of 1.8 times 10 to the minus fifth. Guys, don't break my hearts here in sig figs. What's the answer?
4.74. 5.
4.7.
3.
No,
4.73.
Big figs, sig figs start after this.
4.73.
4.7.
Now, I had 4.74 written down, but I probably didn't round appropriately.
That's 4.7. There's literally there's two numbers.
No,
Oh, wait, but the.
I already did it.
remember,
Sorry, Jen.
remember, the
The
pH,
decimal.
I told you
Guys,
that.
ready?
Yeah.
Remember, I gotta explain it so they can hear. For the pH, the significant figures for pH, you're gonna take the number of significant figures in your given, and that's how many decimal places you get. Don't forget.
Wait,
So that's how you do that one.
so then, if the given 5.6, so why would it be 4.7? Or would the given be 0.60?
They both have two sig figs. Both of those have two sig figs. Okay. Does anybody have any questions for the good of the group, or we're gonna shut this off?
I think it should be 0.74.
Yep.
I got 0.74 on
I
mine.
had 0.7.
It's because I plugged in the whole, actual,
I
like,
just
1.84.
That's fine. Everybody will know, I would never count that wrong, 'cause not even I am that nitpicky. Okay?
You are picky.
Does anybody
You are that
have,
picky. You would.
not that nitpicky? They're right, I count it wrong.
You would. Jay Horn would be like, that's the point.
Just because I like people to come and argue with me. Okay, does anybody have any questions for the good of the group, or can we shut this off? Let's shut, what? Okay, shut it off, please. So now,